Bismillahirrahmanirrahim. I'm continuing the same video. This is second part of lecture number 1. As we have studied a function and its representation, the first type was algebraic and symbolic notation. We have studied algebraic notation in the previous lecture. In this lecture, I'll be continuing it for symbolic notation. Now, let us consider a function f of x, that is 2x divided by 3 minus 5 of x. Here we are just going to insert the values of x, different values of x, and we will see that what will be the functional value for that input. In this case, first we are going to insert the value of x as 7. We are randomly taking the values. See, we are multiplying 2 with 7, then 3 minus 5 into 7. We just have inserted the value of x, which we have taken in this part as 7. In the next part, I'm just giving you examples of symbolic notation. Minus 3. Now, instead of x, we'll replace it with minus 3. The function will become like this. The only difference is of the input. Previously, the input was 7 and here the input is minus 3. A, you can use any variable or any constant number, it can be any integer. So when you are replacing x with a, the functional value will become 2a divided by 3 minus 5a. So now you don't need to worry since the input is c plus 60. Insert the value of your input the same way. 2 is our formula and we have inserted the value of x as c plus 60 divided by 3 minus 5 into x was the input and instead of x, I have replaced it with c plus 60. So this is the symbolic notation. Now second type is numerical. Numerically, how can we represent a function numerically? So here we go. The numerical representation of a function f is just a table of values in which the entries in one row or column is the domain and the entries in the other row or column is the range. Here, this is your domain. These values of x represents your domain and these values, which is f of x, it is also equal to y, are the values of your range. Now in this example, at the left, the domain is the collection of entries in the first column, that is 2, 3, 5, 1, minus 2. And the range is the collection of entries in the second column, that is 11, 9, 12, minus 7 and 9. So the correspondence is when you are inserting the value of x as 2, the functional value will give you the answer as 11. When you are inserting it as 3, it will give you answer 9. When you are inserting the functional value 5, it will give you answer as 12. So these values represents your range and this x represents your domain. It is easily checked whether a table of values is a function or not. So for example, the table of values at the left is not a function since there are two values associated to the number 3. So you can see that when you are inserting 3 and the same functional value gives you answer as 9. And when you are inserting 3, again the functional value gives you some different answer, minus 7. So this shows that the function f of x is not a function. So finally we conclude that f of x is not a function because with two same inputs you can't get two different outputs. Now the third representation type is graphically. How can we deduct whether a given graph is a function? The given graph shows that it is a function or not. So we'll be using a vertical line test to check whether the graph given shows a function, it represents a function or not. So Here is a vertical line test. A graph G is the coordinate plane. In the coordinate plane is the graph of a function if and only if each vertical line meets G in at most one point. This is the graph at the left. So we see that it appears that the answer is yes. Why? Because I repeat that you have to focus that your vertical line will be intersecting this graph at only one point. I repeat that we can apply vertical line test to check whether the graph is a function or not. So now you can see that this vertical line, it is intersecting this graph at this point, at this point, and at this point. So this function, this graph is not a function. Vertical line intersects the graph at 3 points. So we can easily conclude that this is not a function. Now the fourth type is verbal. How can we represent a function verbally? So for that, check this. A function f is represented verbally if f is expressed by a description in words, as I have explained it before in the very first slide, that how can we represent a function f of x. We have already used the notation f of x, which shows that it is a function. Examples are v of t is the instantaneous velocity at time t, h of t is the height at time t of a ball which has been thrown upward. Means this is the way how can we represent a function. We can write it f of x, g of x, h of x, a of r, h of t, v of t. We can use any notation. And if we are using notation like this, it means that we are dealing with the function. Now we are going to discuss the exercise problem. Now to determine how to find domain. How to find domain of a function. We can take all values for the domain, not including division by 0, square root of a negative number, and log of negative numbers. So we have to keep these 3 points in mind while defining or determining our domain of any function. Now how to find range. Are there any restrictions on the range? Can y be equal to all real values? But just looking at the function, it is difficult to tell. However, by solving for x, the solution becomes apparent. So now we are going to take few mathematical steps to define a range of any function. So here are the points. Put y in the place of f of x, then separate x. That is y equals to f of x. See, we have written y equals to f of x. Now we are going to separate this x from the function. So if we are shifting f on the other hand side, it will become inverse, f inverse of y, which is equal to x. Then we know that f of x equals to x plus 5. This is our example. We are solving this function and we are finding its range. So your first step will be to write the function, the basic function y equals to f of x, since we know that y is always equal to f of x. So separate x from here, it becomes f inverse of x. Now x is separated from the function. Now in the next step, you are going to place the value of y, which was y equals to x plus 5. So separate x from this function. So if you are shifting 5 on the other hand side, it becomes x equals to y minus 5. The next step will be we put f inverse of y in the place of x. because f inverse of y is equal to x. So instead of x, we can also insert it as f inverse of y, or instead of f inverse of y, we can replace it with x. So in this function, instead of x, we will be replacing it with f inverse of y. Now we will change the dummy variable. This is the dummy variable with x. So instead of y, replace the value of x. So in this step, we have replaced the value of x. Then we check the domain of f inverse of x, which is our range. Now what is the range? Domain of this function is the range of this function f of x, that is x plus 5. Let's discuss the exercise. Exercise 1.1. It is very simple and easy. Question number 1 of it is identify the independent and dependent variable for the following problems. I have told you before that if you are dealing with the function, let's take this as an example. Question number 1, part A, p equals 264d. Now this statement represents a function since the value of p is depending upon d. So we can say that independent variable is d and dependent variable is p. This is the solution for part A. Next part. So check it that which variable is dependent and which one is independent. So we can see that independent variable is c and dependent variable is f. In this case, independent variable is f and dependent variable is c. You can also solve d part, e part. It's very easy. Second question of it is evaluate the following function for the indicated independent variables. So let's solve this question. You can see that which notation are we using here. I have taught you in my previous slides. F of x is this. This is your function. The input given is 3, minus 4, a plus h. You have to check this functional value for all these inputs. This is the first part. The answer for f of 3 is 43. And then when you are inserting x as minus 4, the answer for it is 15. And then instead of x, you have to put in the value as a plus h. You don't need to get confused. Just insert the value, simplify it, and get the functional value. Add, subtract the like terms, and just solve it. This is its b part. You can also solve it on your own. Here is the c part. Now see, in this part, when you are inserting the value of capital R as 3, the function does not exist because in the denominator, it gives you answer 0. So you have to write a statement that the functional value does not exist. This is its second part. This is your d part. In all the parts, you will be given with the functional value. You will only be inserting its input. The input is defined here for the 3 functions. You have to find 3 values for 3 different inputs. That's all. Thank you so very much.